Alright, now let us look at the questions on thin lenses. Okay, a biconvex lens forms a virtual image of an object placed at a distance 5 cm from lens. If the image form is 3 times bigger than the object, determine the position of the image, find where is the image form, calculate the focal length of the lens, sketch a ray diagram to show the image, how the image is formed, state the characteristic of image form. Okay, let me tell you what I straight away, because I already have all the concepts, all the acronyms, from the first glance of my concept, already got all the answers, especially the last questions. The characteristics of image form, I straight away can get the answer already. And you know why? Let me tell you. First of all, he says that this is a biconvex lens. Okay, this is the important thing. Okay, this is a biconvex lens. So, have you ever seen a biconvex lens? It's a fat guy, isn't it? The fat guy. The fat guy, do you think is a kind of that? I mean, the fat guy will focus a light or diverge a light. The fat guy. Remember? The fat guy always focus a light, isn't it? This one, you see? You see? The fat guy always focus a light. So it's always, what we can say is always converging. Yeah, it's always converging. The thin guy is always diverging, isn't it? So we know the fat guy is converging, the thin guy is diverging. So biconvex lens, of course, it is converging. What I can know from my first perspective is this is the fat guy always focus a light, converging. It form a virtual image. Oh, it form a virtual image. So what can I know from here? Virtual image. First of all, what I can know is V must be negative. Virtual image. And virtual image from the review, from review, I can know it is virtual must be upright. Virtual must be from here. I know it is upright image. Upright image. So if upright, that means I can know this is magnification must be positive. Yeah, this is the first thing I know. And he said the image form is 3 times bigger. Oh, this is about the magnification. 3 times bigger. The image is 3 times bigger than object. So this is magnified. This is magnified. Understand or not? Magnified. 3 times bigger. Magnified. 3 times bigger. That means the value of magnification is 3. And it is positive or negative 3. It is, of course, virtual must be upright, isn't it? Virtual review. Virtual must be upright. So magnification must be value positive. I can straight away put magnification equal to positive 3. Positive 3 is not negative 3. Yeah, it's not the negative 3. Which is wrong. Yeah, wrong. So it must be positive 3. Positive because it is upright. Because it is upright. So what kind of image is formed? Virtual, upright, magnified. This is virtual, upright, magnified. Virtual, upright, magnified. This is a virtual upright magnified. Converging one can only form virtual upright magnified. If diverging, if the thin guy, the diverging is always form wood. You understand? It's always form wood. Wood. Diminished one. It form the diminished. But this one is virtual upright magnified. And what is the object distance then? This object distance 5 cm. How to find a virtual upright magnified image for this converging lens? The object distance must be very, very near. To form a virtual image for a converging lens, the object must be very, very near to the lens. That means the object distance must be u less than f. That means the focal length of this biconvex lens must be bigger than this object distance given. Yeah, let me show you. This just now, so I know it is a virtual upright magnified image. So that means the last question I already got the answer. State the characteristic of the image form. It must be virtual upright magnified. I know already. Because I have all the acronyms already. Why I know the acronyms? Because of this. I already know this one already, the acronyms of this. So it's for me easy. Yeah. Yeah. Let me show you. This is Voom. Okay. So how to get a virtual image for a converging lens? The object distance u must be less than the focal length. What is the object distance? 5 cm. Here already give you 5 cm. You see that? This is the u. And that means the focal length need to be bigger than this 5 cm. The focal length can be maybe and this focal length must be converging. You see? This converging, that means biconvex lens, the fat guy is converging. Converging means it must have a real focal point. Real focal length. The f must be positive value. I also know the f must be positive value because it's converging. Converging f must be positive. So that means and then the u is less than f. That means since the u is already 5 cm, that means the u can be positive 6 cm, can be positive 7 cm, as long as bigger than 5 cm. Understand or not? The u must be less than this focal length. This is the thing I know. Yeah. So is my guess correct? Is my guess correct? Yeah. Yeah. You see that? Why I know all the why I know about the Voom? Because of the, you see that? Because of this what we have learned before. The converging lens can form reed, wreath, rim, infinity, and finally Voom. Voom is this one. This is the one lah. This is the one. When is it formed Voom? No. This is for mirror. For the mirror. For mirror. I'm talking now about the lens. Same thing. Same thing. Reed, wreath, rim, infinity, and Voom. This is the one. This is the one. Voom. When do we find Voom? That means the object distance I5 is for O5. When object distance must be less than the focal length. This is the object distance. This is the focal length. Do you see that? This is the focal length. The u must be less than f. U must be less than f to form the Voom or convex lens. This is a biconvex lens. It's a converging. Converging means it must be f must be positive, diverging must be f negative. I know all this because I know the acronyms. Yeah, I don't need to calculate. I don't need to do any calculation. I already know the answer. Okay. So to form the Voom, the concave lens, the thin guy, can also form virtual image, but it only form wood diminished one, not the magnified one. If for magnified one is the converging one. Yeah, for converging. The wood diminished one is for diverging. Understand? Okay, now let us look one by one. That is the first thing I know. First thing I know. See, let's look at the answer first. Okay, never mind. I already can guess the focal length must be bigger than 5 cm. Okay, because u is less than u is what I can say is u is 5 cm. So that means it must be less than the focal length. Focal length can be 6 cm or 7 cm. As long as bigger than the 5 cm lah. So let's see if our guess correct or wrong. Yeah, let's get. And is it Voom or not? Is it Voom? Is it upright? You didn't mention upright, but I know it's upright because I know virtual must always upright. Okay, let us look one by one. Yeah, M is positive and the V is negative. All these things is the thing I know from the first glance. So now, determine the position of the image. That means the question asks for image distance. The V must be negative. Is it correct? V must be negative. Okay, it's a virtual image. So now let us look. It gives us the magnification. Magnification is 3 times bigger. So what I can say is like this lah. This is a biconvex lens. So first of all, you begin drawing the incident ray and reflected ray first. Remember, must draw the incident ray and reflected ray first. Then only you can compare, get the positive or negative for the U, the V, and the R. UV and R. So now, okay, he gives us an object distance 5 cm, and then it is a virtual image. Virtual image must be upright. And then since it's a biconvex lens, and then he say the image form is magnified. So magnification is equal to 3, and because it is virtual must be upright. So that's why m equal to positive, because upright means, if upright means the magnification is positive. Okay, virtual means v negative. Okay, virtual means v negative. Upright means m positive. M is positive 3. So virtual upright magnified. So this is the acronym. Virtual upright it's not the virtual upright diminished. Okay, so it is virtual upright magnified, and it is this biconvex lens. So we can conclude that this biconvex lens is a converging lens. Because only converging lens can form boom, but the diverging lens can form only wood. Only this one lah. This is the thing, yeah. Boom is over here. Wood is for the diverging lens. Wood is this. See that? No. Now let us look. So this we can know this converging. So we can know the biconvex. This biconvex lens have f must be positive value. If converging lens, the f must be positive. So is it correct? Is it true? Let us look. Let us calculate. Let us begin our calculation. So we have the magnification equal to positive 3. So just substitute positive 3. Just substitute positive 3. Okay, positive 3 for magnification equal to negative. The negative you must have. Remember, the negative. This equation have negative sign. And then what is our v? We need to find the v. Find a v. Our object distance is 5 cm. Okay, let us maintain at let me look. Okay, maybe we can maintain at 5 cm. Maybe we can maintain the unit as 5 cm. Yeah, just put as 5 cm. Just put as cm. When you don't substitute the SI unit, when you don't substitute the SI unit meter, you don't convert to meter, make sure you need to write the centimeter there. Centi. Okay, if SI unit, you no need to put the unit. But if you are not using the SI unit, like centimeter, you must substitute the unit. Understand? If you are using SI unit, if you are using SI, no need unit, no need to substitute unit. But if you are non-SI unit, you need to substitute unit. Understand or not? You need to substitute unit. Because we want to make sure you maintain the correct value. So v equal, if you don't put centimeter, the examiner will minus marks. Yeah, if you don't put the unit for the non-SI unit during your calculation, if you don't put cm here, the examiner will minus 1 mark. Yeah, you just put 5. If you just put 5 instead of 5 cm, the examiner will minus 1 mark. Okay, so if you are using non-SI unit, make sure during calculation you must substitute the non-SI unit cm. Okay, not just the value. Okay, the calculation must have unit, the final answer must have unit. Okay, so v equal to so I get the v equal to, got negative. Negative, my answer is 15 cm. V is equal to negative 15 cm. So what does it mean by the negative sign here? So it is a virtual image. Yeah, truly, it got a virtual image. Correct. Correct. Got a virtual image. Where is it from? Yeah, you will ask, where is it from? Is the image from? Remember how to get the position? Virtual image, V negative. V negative, is it same side as refracted ray? V we compare with who? V we compare with, look at the notes. only the object distance compared with incident ray. The rest, image and radius compared with refracted ray. So now, my V is negative. See, my V is negative. That means my V is negative means what? My V is negative means it's opposite to refracted ray. My image form. My image is not formed same side as refracted ray. My image is formed opposite side to refracted ray. So this is my image. This you see here. This is my object, and this is my image. My image. Just now my U is of course positive, because same side is incident ray. But my image distance must compare with refracted ray. My image is formed here, opposite to refracted ray. My V is negative. V negative means opposite. V negative means opposite to refracted ray. It occurs at the no light, at the place with no light. So opposite to refracted ray. So the image is not formed over here. The image is formed over here. So the image you got here is you got V here is negative. Why V negative? Because opposite to refracted ray. That means if my eyes is over here, if my observer is over here looking at the ladybird, I can see a magnified image over here. I can see what I can see is this one lah. I can see this one. My eyes looking at the ladybird, I see a bigger image over here. The image is formed opposite side of the refracted ray. See the bigger image over here. Yeah, it's a virtual image. It cannot form on screen. It cannot form on screen because there's no light. The refracted ray already go to the other side. So there's no light to form a real image at the screen over here. There's no light over here. So what you can see is just a virtual image through the lens only. Cannot form on this image cannot form on screen. Understand? Okay. So now and also upright. You see an upright image. You don't see this ladybird inverted because this virtual image is always upright. So you see an upright ladybird, and it is magnified 3 times. Okay. This is the thing I see lah through the lens lah. Yeah. If the observer is over here, seeing the lights come from the ladybird. The lights come from ladybird refracted to your eyes. The light enter your eyes. When the light enter your eyes, you see a bigger ladybird upright image, a magnified upright image through the lens. You see. Then, okay. So now calculate the focal length of the lens. Calculate the focal length. So let's calculate. Is it my guess f must be positive? Let's find out. So calculate 1 over u. My u is 5 cm. Remember, substitute the unit. You must have unit together because you are using non-SI unit. 1 over v. My v is negative. The negative value also must substitute. Negative 5. This is negative 15. Negative 15. The non-SI unit must substitute also, and equal to 1 over f. So what is my f? I got my f equal to positive value. Yes, my f is positive value, positive 7.5 centimeter. So what is mean by this positive? What does it mean by this positive? That means my biconvex lens is a converging lens. My f positive means my biconvex lens is a converging lens. This conclude that it is a converging lens. Understand? Converging lens. Now, sketch a ray diagram. So my guess is correct. Wait. My f is 7.5. It is bigger than the 5 cm to form the boom. So the object is object must be very near to the lens to form the virtual upright magnified. So correct lah, my guess. my focal length is more than 5 cm, 6 or 7, and I get the answer is 7.5 cm. Yeah lah, 7.5 cm. So it's bigger than the U. It's bigger than the U. So we can see the U is less than F. Yeah, the U is less than F. My U is only 5 cm. U is only 5 cm. U is less than F. Okay, good. My guess is all correct. Now the next step is I need to what? I need to draw the ray diagram. I need to show the ray diagram to show the formation of the image. So okay, I want to solve the last question first. Okay, you know the answer. Virtual upright magnified. Okay, sketch a ray diagram. How to sketch a ray diagram? So first of all, yeah, my object. You see that? This is my lens. Remember, my focal length and the center curvature must equally spaced. Maybe you can put this one as 2 cm from this one also 2 cm. From the lens to the focal length and focal length to center curvature must be equally spaced. You cannot be focal length nearer to the. You cannot be like that. Cannot be like the lens like that. You cannot put F over here, center curvature very near to each other. This is wrong. Understand? So make it equally spaced. Okay, let me rub this off. Okay, let me rub that off. Yeah, must be equally spaced. Now, object must be less than F lah. Remember, my object is only how far? My object distance is only 5 cm. Yeah, my object is only 5 cm. Yeah, this is my object. My object is only 5 cm, but my focal length is just now 7.5 cm. Focal length is 7.5 cm. This is correct. Yeah. All right. So let me rub this off now. So I need to draw the image. I need to draw. Remember how to draw? This one, ray 1 is parallel to focal point. So let me show you. And this fat guy always converge a light. So let's draw ray 1 first. Ray 1 is parallel to focal point. So ray 1. This is the ray 1 lah. Ray 1. Let me highlight. Let me use highlight. Ray 1 parallel. Show you. Let me show you. Okay. Parallel, and then parallel. Yeah, this is a parallel. This parallel first, and then go to the focal point. Go to the focal point. Okay. Go to the focal point. Parallel, go to focal point. And then this is the ray lah. You must draw what I can see from here. I can see a straight line. Behind. I can see a straight line behind. Yeah, I can see a straight line. I thought this light come from a straight line. Understand or not? And then the next one is ray 2. Ray 2 is focal point to parallel. Ray 2. Let me use the green one. Yeah, green grass. Okay. Focal point to parallel. So focal point to parallel. How to get focal point? Actually, it's from here. Focal point, then back to focus parallel. You know, it's always focus the light. Focal point. This is actually focal point. And then this is what we call focal point, and then parallel. Understand? So my eyes, again, what I see my eyes. I thought this light actually come from straight line. I thought it come from straight line over here. Behind. Understand or not? That this light come from a straight line. Must draw a dotted line behind. Yeah. And now I already draw the 2 second ray. So actually 2 rays already got the intersection point. So the intersection point is over here. Over here, so the image is formed over here. It's a dotted line because it's a virtual image. Upright, you see, upright and magnified. Virtual. So from here, I can say it is a virtual upright magnified image. So the last questions ask, state the characteristic of image form. Virtual upright magnified. Just write the answer. D is a virtual upright magnified image. Boom. Yeah, boom. Okay, virtual upright magnified. You must when you draw the ray, you must have arrow. Understand or not? You must have arrow. Don't just draw the ray light. Don't just draw the ray light. You know, don't just draw the ray light. Don't just draw the ray light like this and like this. No, don't. You must add the arrow. You must add the arrow. And then you must label. When you label the image, virtual must be dotted line. Virtual must be dotted line. You must have arrowhead, and then you must have label. The object also you must label. Understand or not? Your object must be labeled. And then the light always reflect from the straight line. You always use a straight line to represent the lens. Use the straight line in the middle to represent. Understand or not? The light all reflect from the straight line in the middle. Okay, the last line I haven't drawn. The last line is what? Last line is optical. The light pass through the optical center undeflected. This one lah. Pass through optical center undeflected. That means like this lah. That means this one is a blue color. I use blue color. Okay, blue, blue, blue. Okay, the light passes through the optical center. Yeah, that means the center of the lens undeflected. Undeflected. That means what I can see is if my eyes looking at this ray, I thought that this ray come from a straight line. Come from a straight line behind. Understand or not? I thought that this ray come from a straight line. So these three ray, the green one come from a straight line. Yeah, come from a straight line. The red one also come from a straight line. The blue one also come from a straight line. All of them intersect at the same point over here, and which form the image. Virtual upright magnified. Remember, when virtual image, need to use dotted line, not the full line to represent. To draw like full line like that. If you draw a full line, it is wrong. You must draw dotted line. This is correct. Okay, dotted line. Okay, so that's all for these videos. Okay, hope you enjoy. Yeah, hope we all got all the concepts. We have several questions more to discuss. Okay, thank you for your time. See you in the next video.